Okay, so we know that atoms are made out of protons, neutrons, and electrons. It's the amount of protons that determine what atom it is. If I change the number of neutrons, it's still helium. If I give it different electrons, it's still helium, although it does become an ion because it doesn't have the same number of protons and electrons. If I change the number of protons, it does change the atom. So anyway, so atoms are made out of protons, neutrons, and electrons. In this little animation, I can make my own atom, and so I'm splitting it, aren't I? But actually, I'm splitting the nucleus of the atom. When we say split the atom, because I said that in my last video, an atom is almost entirely empty space. If I take away an electron, or take away both electrons even, I'm splitting the atom. I'm not splitting the nucleus of the atom, and in fact, whenever we do any sort of chemical reaction, or even whenever we get something to conduct electricity, we are splitting the atom because we're removing electrons from it, or giving it electrons from another atom. So we're splitting the atom there. But when we say splitting the atom, we actually mean splitting the nucleus of the atom. So that might be something like, well, in fact, let's have a quick look at what that would entail. We've got a big, massive atom here, or nucleus of an atom, 235. It's got, I think it's got 95 or 92 protons in it, and then the rest of them are neutrons. What happens is we can give it another neutron, goes to the 236, and then it explodes and splits up into these other two atoms. And if you get a bunch of them together, then what happens is you saw those other little tiny, if I just do that again, if I just do it just with, let's do 1 or 2, you saw these other neutrons fly off, and if those neutrons hit another one, then that's going to miss, isn't it? Then I could start a chain reaction. But so let's just put loads of them in there. Let's set that off, and that is a chain reaction. Now, if we let the chain reaction go out of control, that is what a nuclear bomb is. Okay, so we have another one over here. So we can increase the concentration of uranium-235, and then we give it a neutron. It gets absorbed by one, and then a load of energy gets released, and that is essentially a nuclear bomb we've got right there. Okay, so that's what a nuclear bomb is, or a fission bomb. It's not a hydrogen bomb. Hydrogen bomb actually does the opposite to what we're doing here. A hydrogen bomb, well, it doesn't actually. It does both. So what we've just looked at there is something called fission, and that's where we break apart an atom break apart a nucleus into 2 parts. Well, actually 5 parts in that case. 2 big chunks and then 3 little neutrons. A fusion is when we join 2 atoms together, or 2 nuclei together to make something new. The sun, our star, uses that. It uses fusion to make its light, to make the energy, to make the heat and the light that we see. So if we might get a a proton or a hydrogen nucleus, and that would join to another type of hydrogen, which has also got a neutron attached to it, and they join together and form this new type of substance with 2 protons and 1 neutron, and therefore that's going to be helium with a mass number of 3 and atomic number of 2. Then they join together and they form new elements, and that's basically what's going on in our sun right now. So we have a similar sort of fission reaction going on inside a hydrogen bomb. It's called a hydrogen bomb because it is made because the main reaction that's producing all the energy is between these 2 hydrogen atoms. So like that, okay? So that's what's going on in a hydrogen bomb. All right. Okay.